This is worksheet 2 of the stoichiometry packet. Once you have mastered worksheet 1, worksheet 2 should be significantly easier because it's going to be a very similar type of problem with only one difference. Worksheet 1 was a mass to mass problem, and worksheet 2, you can see, is a mass to volume problem that we're solving. So what that means is, and you want to write this down, in these problems you will be given information in grams. So you'll be told how many grams you have of a reactant, and you will be asked to find the number of liters you have of another compound. So in worksheet 1, you were given grams and asked to solve for grams, which meant that you had to calculate the molar mass of the compound you were given information about, but you also had to calculate molar mass for the compound that you were trying to solve for, your unknown, right? In this case, if you're given information in grams, you will still have to calculate a molar mass for the compound that you're told about in grams. But because you're going to try to solve for something in liters, you do not need to do a second molar mass calculation. Instead, you just need to remember what we know from the moles packet. 1 mole of any gas has a volume of 22.4 liters. So we need to use this conversion that 1 mole equals 22.4 liters in place of one of the molar mass steps in our stoichiometry problem. But that factor label stoichiometry problem is still going to be 3 steps. And the second step is still going to be the mole to mole step using the coefficients in the balanced equation. So let's go ahead and do an example. In this example, they're asking us to solve for volume, measured in liters, of oxygen, if we start off with 90 grams of water. So just like in the first worksheet, they're giving us a balanced equation here. And we are going to pull information out of the problem. We've been told we have 90 grams of water, and we're trying to solve for the number of liters of oxygen. That could be a question mark instead of an X. And just like in worksheet 1, in order to avoid a very common mistake, I'm going to really encourage you to go ahead and cross out that H2. In this particular problem, you're not going to deal at all with the hydrogen, and so you don't want that to sneak into your calculation. The second thing, just like in worksheet 1, is we are going to look at the coefficients here, the big numbers in front of the formulas, and so that tells us we have 2 moles of water. And if we start off with that, we are going to produce 1 mole of oxygen. So now we are ready to set up a factor label problem. And I want you to think as we're going through this about how similar it is to the factor label problem in worksheet 1, because that's going to really help you here. All right, also note over here my 1 molar mass calculation. I'm only going to calculate a molar mass for the thing that I'm told about in grams, which in this case is the H2O. All right? So don't go automatically calculating 2 molar masses because you'll waste time and probably confuse yourself. So when I set up my factor label problem here, I have been given how many grams of water I have and asked to solve for liters of oxygen. My first step, just like worksheet 1, is going to be the molar mass of the thing I've been given information about, in this case the water. And again, I'm not just going to put 18.02 grams on the bottom and 1 mole on top. I'm going to specify that because I'm talking about grams of water here, I'm talking about grams of water here, and therefore moles of water on the top. Including the formulas is very important because it will help me in my mole to mole step. This is the one where I go back and look at the coefficients. If I start off with 2 moles of water, I will produce 1 mole of oxygen. So I put my 2 moles of water on the bottom, my 1 mole of oxygen on the bottom, or excuse me, on the top. How did I know that? Because I looked at what was on the top of my first factor label step. If I want to cancel out moles of water on the top of the first factor label step, I've got to have moles of water on the bottom of the second step. Then, here's where things get different from worksheet 1. In worksheet 1, I wanted to end in grams. So I had to use another molar mass, the molar mass of the unknown. Here, I don't want to know grams of oxygen, I want to know liters of oxygen. And so my last step is going to use the conversion that 1 mole is equal to 22.4 liters. I put the 1 mole of oxygen on the bottom of the third step because it's on the top of the second step. I put the 22.4 liters of oxygen on the top, which leaves me in units of liters of oxygen, which is good because that's what I'm trying to solve for. Now I'm going to go through and I'm going to do my calculation. 90 times 22.4 divided by 18.02, and again divided by 2, which gives me a number that I should be able to round to 56 liters of oxygen. Notice my units in these problems are going to be liters, not grams like worksheet 1. Things that this problem has in common with worksheet 1. 3 steps, always going to be in this whole packet. I still start off with the molar mass of the given. My second step is still the mole to mole step based on the big numbers in front of the formulas in the equation. But the third step is the different step. All right, we can look at one more example. In this example, we are told that we have 80 grams of methane, CH4, and they want to know the volume in liters of oxygen. In this case, we are given information, 80 grams, about one reactant, and asked how many liters of the other reactant we would need. So we're not dealing with either of the products. Cross them out. I'm going to set up a factor label problem that is going to require a molar mass calculation. Again, just one. The thing that I'm given information about in grams is the thing that I need to calculate a molar mass for. So, I am told that I have 80 grams of methane. I want to find the number of liters of oxygen. My first step is going to be the molar mass of the given, which I calculated to be 16.05. The 16.05 goes on the bottom because its units are grams of methane, which I have on the top. That leaves 1 mole of methane on top of my first factor label step. And that's how I know that the moles of methane are going to go on the bottom of the next step. Again, write the formulas. Not enough to just say 16.05 grams on the bottom and 1 mole on top. Then you wouldn't know what to do for your mole to mole step, right? You might end up with the 2 moles of oxygen in the bottom and the 1 mole of methane on the top, and then your answer would be wrong. It'd be half what it should be. All right. Again, where did these numbers come from? This 1 mole of methane is because I've got 1 mole in my equation, that big number in front of the methane. In this case, there's not a number in front of the methane, so we assume it's 1. This 2 moles of oxygen, where does that come from? I've got 2 moles of oxygen because there's a big 2 in front of the oxygen in the equation. My final step now, because I want to end in liters, not grams, is using the conversion that 1 mole of oxygen is equal to 22.4 liters of oxygen. So this third step is a liters to moles step, right? So I put moles of oxygen on the bottom because in the previous step it was on the top, leaving my units in liters of oxygen. I multiply 80 times 2 times 22.4 and divide by 16.05, which gives me a number that I should round to 223 liters of oxygen. Again, make sure your units are in liters. All right. When you come to class next, we'll be working on some problems that should be very similar to these. And hopefully you can move through these more quickly than worksheet 1 because you see the similarities between this worksheet and the previous.